auxiliary angle method. So we have root 2 cos minus root 5 sine in the form r cos plus. So for cos plus, we use the compound angle MF19 formula. For plus, the sign on top, we have to use minus. So cos minus sine. So we express this guy in this form, and we use the compound angle formula to use cos minus sine, and without the square brackets we have r cos minus r sine, and then we analyze the coefficients on the left and on the right. So on the left, for the variable cos x, the coefficient on the left is root 2, and on the right we have r cos. That's why we have root 2 equals r cos. And for the variable sine x, on the left we have minus root 5, on the right we have r sine. Hold on, let's use green. So on the left we have root 5, and on the right we have r sine. That's why we have root 5 equals r sine. So now we use the fact that tangent equals sine over cos in the MF19. So since tangent equals sine over cos, we just divide these equations. So r sine divided by r cos cancel out to r. Sine over cos is tangent. So we use inverse tangent. We get the angle in degrees 3SF, 3 decimal places. Yes, 3 decimal places. And because of the fact that in the MF19 cos squared plus sine squared equals 1, we use the sum of the square of the blue and the green. So for the blue, r cos, r sine, root 2, root 5, we square everything and then we add, we get r squared cos squared, r squared sine squared. We pull out the r squared, we have cos squared plus sine squared, which is 1. So that's why we can just find the r. It is square root of, from here, root 7. Okay, so square root 7. So in conclusion, the r is root 7, the alpha is this guy here. Next part. So we have to solve this equation. Previously we have this from the first part, but this time we're not using x, we use 2 theta. So we replace the x with 2 theta, 2 theta, 2 theta. And the left hand side is exactly the same here. We can replace it with 1. And then we divide both sides by root 7. And now we need to find the base angle. So the base angle is using cos, so it's got to be inverse cos. And we have to use something positive. This is positive, so inverse cos this, we get the base angle in the first quadrant. Now for the domain, this domain is for theta. The angle we are dealing with is not just theta, it's 2 theta plus something. So we gotta modify the domain, multiply everything by 2, add everything by 57.688, and this is the actual domain we are using. So between 57 degrees to 417 degrees, and this is the base angle. So that means we can use the first quadrant angle. It's in the domain. For cos positive, we can only use first quadrant or fourth quadrant. So we can use this, we can use this, and that's all we can use. So first quadrant is just the base angle, is the first quadrant base angle, and the fourth quadrant is 360 minus base angle. And we still have to solve for theta, so we subtract 57.688 from both sides, and then we divide both sides by 2. We get theta in 1 decimal place, angle in degrees. We get 2 solutions. Alright, I'll see you.